Hello, everyone. Welcome back. Today, we're going to be talking about classifying triangles and how we can classify triangles as either equilateral, isosceles, or scalene, and also right or non right as well. So, we're going to talk about some characteristics of these triangles and also how sometimes you just need to show that one of these things is the case to show that both of them are the case, and therefore it's that type of triangle. So, we'll get into that in a sec here. All right, so the first type of triangle is an equilateral triangle. And an equilateral triangle, all sides are equal and all angles are not only equal, but they also must be 60 degrees, right? Recall that any triangle, the interior angles must add up to 180 degrees. And so if all three angles are the same, then it would follow that 180 divided by 3, which is 60, would give us any one angle of that equilateral triangle. Now, the thing here is that we actually only have to prove one of these things is true to prove it's an equilateral triangle, because if one is true, the other one is also automatically true, right? If all sides are equal, then that means all angles must be equal, which means all angles must be 60 degrees, right? Or if we know that all angles are 60 degrees, then we know all sides must be the same as well, right? And so if we just prove one of these things is true, then we know that both of them are true and it's an equilateral triangle. All right, let's take a look at an isosceles triangle. If we can prove that exactly two sides are equal, it must be isosceles, right? And if exactly two angles are equal, then it follows that exactly two sides must be equal as well. There's no way that we can have two angles be equal and not have two sides be equal on the same triangle. And so if we prove that two angles are equal, it follows that two sides are equal and it's isosceles. With a scalene triangle, all the sides and angles must be different. So no two sides are the same, which would follow that no two angles are the same. Or likewise, if we know that all the angles are different, then no two sides can be the same. They all must be different as well. So again, with this one, if we prove something about the sides, then it follows that there's something similar that follows about the angles and vice versa. So every triangle is either equilateral, isosceles, or scalene. There's no third option, or I guess fourth option there in terms of those ones. So these three are kind of together, right? It's everything we decide is one of these. We classify it in one of these three ways. But then there's also right triangle. So an isosceles or scalene triangle might be right or non-right. So this is a separate characterization. We first characterize as equilateral, isosceles, scalene, and then we go back and we look and see, okay, is it also a right triangle? Now, with a right triangle, one angle is 90 degrees, right? So that means that if something's a right triangle, it can't also be an equilateral triangle, or vice versa. If we know we have an equilateral triangle, it's automatically not a right triangle, because an equilateral triangle, all the angles must be 60 degrees, whereas with a right triangle, one of the angles must be 90 degrees, and so that those things contradict each other. And so an isosceles or scalene triangle, though, can possibly be a right triangle. And to verify that it's a right triangle, we would have to show that one angle is 90 degrees. If one of the angles is 90 degrees, then it's a right isosceles triangle or a right scalene triangle. And also, if if not, right, if that's not the case, if all the angles are not 90, then it would just be a non-right isosceles or non-right scalene. So isosceles and scalene might also be a right triangle. Equilateral cannot ever be a right triangle. All equilateral triangles are not right. Okay, so that's kind of our characterization here. Let's go ahead and move on to the next one. So here it tells us, or it asks us to classify the triangle with these vertices and also state whether or not the triangle is right. So first they want to know, is the triangle equilateral, is it scalene, or is it isosceles? And then they also want to know, is the triangle right or non-right? So the first thing I'm going to do here is I'm going to figure out what type of triangle this is. Now, how can we do that? We can either figure out the angles or we can figure out the sides. So I'm going to go ahead and figure out the sides of the triangle. Recall Pythagoras' theorem, right? That the length of a side, so length of AB, for example, is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared, right? This is going to be the length. And here when I say y1, y2, x1, x2, I'm meaning the corresponding coordinates for A and B because we're finding length A and B. Okay, so let's do that. All right, so -4 minus 6. And then let's see, -2 minus -6 like that. So that's going to be 100 plus, let's see, 16. So it's going to be root 116. Okay, so that's our answer for length AB. It's root 116. Now let's see if any of these other ones are 116 as well, or if none of them are. Because maybe they are, maybe they're not. I'm not sure. Okay, so let's do that. Let's find length of BC. So same thing, we're going to do y1 minus, or sorry, y2 minus y1, which is going to give us 0 minus -4 squared. And then we're going to do x2 minus x1. So that's going to be equal to 4 squared plus 10 squared, which is also equal to root 116. Okay, so far, two of the sides are the same. So this automatically, as we know, it can't be scalene. It could either be isosceles or equilateral. It just depends on what we get for our last one. What's the length between A and C? Let's find out. Actually, I do think it'll be different here, but let's actually show the evidence of that and make sure. Okay, so here we have 0 minus 6. That's going to be 6 squared. And then we have 8 minus -6. Yeah, this is going to be different. So that's going to be root 36 plus 14 squared. And let's see, what is 14 squared? I mean, already we know it's not going to be the same as before. Then plus 36. So root 232, which is different from root 116. Okay, so automatically right now we can already classify this. We can already go ahead and classify this as an isosceles triangle, right? Because two of the sides are the same. Okay, now since it's an isosceles and not an equilateral triangle, there's also a possibility that it's a right triangle. Okay, so we would have to check if any of the angles is 90 degrees. But one interesting thing with the isosceles triangle is that two sides, or sorry, two sides must be the same, but two angles must also be the same. So those two that are the same cannot both be the 90-degree angles, right? In a triangle, we can only have one 90-degree angle. So if we were to have a 90-degree angle, there's only one angle that could even possibly be. So we just have to check for that angle. And I'm going to actually draw a picture here to show you what I mean here. So let's say we have A, B, and C like this. A, B, C. We know that AB and also BC are the same length, right? We know that these are the same length. These are both root 116. And so the only possibility for what could be the right angle is this one, right? Because these two angles here have to be the same, right? These have to be the same thing. So this is the only angle here with, where we connect at B that could even possibly be the right angle. So we actually don't have to check all of them. We just have to check if this one is or isn't, because the other two we already know are not, right? Because maximum we can only have one angle that's 90 degrees. And so given that those two angles, those alphas, they're the same thing, that can't be 90 degrees. So we just have to check for angle B. Now, how do we check if something is perpendicular or not, or right or not? We need to check if it's 90 degrees with each other. And how do we do that? We need to know if there's negative reciprocal slope. So we need to know if the slope between A and B and the slope between B and C are negative reciprocals or not. So let's first find the slope of AB. So slope of AB would be delta y over delta x. So that would be, let's see, negative 10 over, let's see, delta x, 4 looks like, okay, which is negative 5 over 2. Okay, so now the big question is for the slope, not ABC, sorry, the slope of BC, is it true or is it not true that this is going to be 2/5, right? Because if this is the negative reciprocal, which would be 2/5, this is a right triangle. If it's anything else, it's non-right. Okay, so let's do that. What's the slope of BC? That would be, let's see, 10. Let's see, 8 minus negative 2 would be 10. 0. Oh no, sorry, that's x. I'm just realizing. So it's 10 down here. And then 0 minus negative 4 would be positive 4. And that's equal to 2/5. Okay, so it is 2/5. So therefore, this is a right triangle. So therefore, it is a right triangle as well. So overall, we know that this is a right isosceles triangle, right? We know it's isosceles because 2 of the 3 sides are the same, and we know it's a right triangle because we showed that the slope of AB and the slope of BC are negative reciprocals of one another, and that means that they cross at 90 degrees, which makes this a right triangle, right? Because a right triangle is a triangle with a 90-degree angle in there. So there we go. We did it. All right, let's actually do one more example here. Here it's asking us to classify the triangle with the vertices -4, -2, -2, 6, and 6, -4, and state whether or not the triangle is right. Okay, so first let's do lengths. Let's find out the length of AB, length of BC, and the length of AC. Okay, so what's our length of AB? Well, let's see, that's going to be the square root of delta y squared plus delta x squared. Okay, so 6 minus -4 squared plus, let's see, -2 minus, I think I've done this incorrectly. Yes, I have. Okay. Well, this should be 2 here. My apologies for that. Yes, because it's delta y, so I've got to keep it straight here. There we go. Okay. So then we have 8 squared plus 2 squared. So that's going to be 64 plus 4, which is root 68. So there we go. All right, so length of AB turned out to be root 68. Let's see what the length of BC is now. Length of BC is equal to, let's see, delta y squared. So delta y is -6 minus 4 squared plus, let's see, delta x, 6 minus -2 squared. So that's going to be equal to -10 squared plus, is that right? Yep. Okay. Plus 8 squared is going to be equal to 100 plus 64, which is root 164. Okay, so those two, so far we can't have an equilateral triangle. We got 2 different ones. Let's see with AC what AC is. Okay, so let's hope they didn't give us a second one that's right isosceles again. Let's hope we got some different ones here. Okay, so delta y squared. So delta y squared is going to be -4 minus 2, or minus -2, sorry, squared, plus delta x. So that's going to be 6 minus -4 squared. So then we're going to have 4 squared plus 10 squared, which is going to be equal to square root of 116. All right. Okay, so already we know this is a scalene triangle. Because all 3 sides are different. Now, given that this is a scalene triangle, we actually don't know which side could or couldn't be 90 degrees. Any of the, not side, angle. Any angle could be a 90-degree angle, possibly, because it's scalene. So we need to check all 3 slopes. So it actually is just, it's actually only really one slope calculation more than the previous one, but there is a little more work to do for this one because it is scalene. And there's 3 possibilities as opposed to just one possibility. So let's do it. Let's find the slope of AB, the slope of BC, and the slope of AC. And if any 2 of these are negative reciprocals of one another, that means we have a 90-degree angle. If none of these are negative reciprocals of one another, then there is not, right? And I also want to add, like, let's say we just do 2 and we already can see that yes, there is, then we can stop there. We can say, yes, it's a right triangle. But if not, that doesn't mean it isn't, right? Maybe the third slope would have been a negative reciprocal with one of the others. So unless we can see right away with just 2 that there definitely is, we need to assume there still could be and continue on and do the third one as well. Okay, so let's find the slope of AB. So that's going to be delta y, which is 8, over delta x, which is 2. So that's going to be 4 for AB. Awesome. All right, what about for BC? We have delta y, which, let's see, negative 4 minus 6. So that's negative 10 over delta x, which is 8. That's negative 5 over 4. And so far, these 2 are not negative reciprocals of one another. So we do need to keep going and see if AC possibly gives us a negative reciprocal of either of these. Okay, so what is the slope of AC? Well, delta y over delta x, negative a fifth. So looks like none of them are. And because none of these are negative reciprocal slopes, we can say this is a non-right. Oh. So because none of them are negative reciprocal slopes, we can say this is non-right. So there we go. All right, well, good work today, everyone, and I'll see everyone next day. Bye, everyone.